In this example, we'll do together, and then I've got two examples that I'll have you guys try on your own before explaining them. So for this first example, um, we have the region in quadrant 1 bounded by y equals 1 minus x, and it's rotated about the y-axis. Find the volume of the solid of revolution using shells. So this is just a line. It's an easy line to draw. It's right there. We're rotating about the y-axis. And so notice I draw my rectangle perpendicular to the axis of rotation. I'm sorry, parallel to the axis of rotation. Oh my goodness. Parallel for shells. So I've got my radius going horizontally and my height going vertically. Now the radius is what gets a little weird. It always trips students up. It's actually too simple that it ends up being confusing. Think about what's going on here with the radius. So the radius is going sideways. So we know we're going to measure from right to left. And also, by the way we've drawn the rectangle, we know it's going to be a dx problem. So we want everything in terms of x. So when we're doing right minus left, in this case, the right end of the radius is always going to line up with whatever this coordinate is on the x-axis. And so it's just x. It's not dependent at all on one of the equations. And that's always going to happen with your radius. Your radius is going to either have, like, either for the right or the left, or if your radius is top and bottom, top minus bottom, could be the top or the bottom, but it's always just going to be x or y for one of these. And then in this case, the left is always going to remain at x equals 0. So it's weird. It's just x. Think about it this way with our height. So our height is top minus bottom. We could say then that the top is just always going to line up with the y coordinate. So the top is y and the bottom is 0. We could say that, y minus 0. The only thing is this is a dx problem, so we'd have to put y in terms of x. And so instead of writing y, we write the equation for y. So that's why we've been doing that up until now. But now we don't need to rewrite it. It's just x. The right-hand side of the radius lines up with the x coordinate. And that's all we need to say. You'll see that also in our next couple examples. That's all that radius is. So that's a weird part. If you need to pause the video to chew on that, definitely go ahead and do that. But once we got these equations for our radius and height, we just plug into our equation. So our equation was 2 pi radius times height dx. So 2 pi, and I'll make this a little smaller so we can see it. So our radius ended up just being x. Our height was just 1 minus x. So there's our equation right there. And then this is an easy one to work out by hand. We just would distribute the x. Then we can integrate. We'll substitute in, and we get volume is pi over 3. So again, all the work is going to be finding these equations. Okay, so here's one that this is ours that we're going to do together. Go ahead and think about this problem now. Before you go to the next video, try to do as much as you can of this, and then you can go to the next video and see how we do it. Check your work.